Welcome back to our channel. Today we are going to discuss about equations of motion in +1. In this first we are taking first equation of motion V equals to U plus AT. What is V here? Suppose we are taking one body. That body is having the mass m. Initially it is moving with initial velocity U and final velocity is V. If the velocity is changing means that acceleration we should consider A and how much time it takes t. So how to derive this equation in +1 we are going to discuss now. Look here, already we know that what is the acceleration? Rate of change of velocity is called acceleration. Rate of change of velocity is called acceleration. We do the cross multiplication. dv equals to a dt. dv equals to a dt. Both the sides take integration. We are taking the integration both the sides. dv equals to integration of a dt. But initial velocity, starting velocity u and the final velocity is v. Here initial we can take it 0 seconds. Then after t seconds that velocity becomes to v. Here integration differentiation cancel. First apply the upper limit minus lower limit equals to a into integration differentiation cancel. You are getting this. So from this v equals to u plus at. This is the first equation of motion. Then second equation of motion we have to prove that s equals to ut plus half at square. S equals to ut plus half at square. So here the body same we should consider. The body is starting with initial velocity s. It is covering s distance in t seconds. How to find out the distance, and that too we should derive that s equals to ut plus half at square. We know that velocity, what is the formula? Rate of change of distance. Rate of change of distance is the speed. Rate of change of displacement is the velocity. In straight line motion we should take both the same in uniform motion. We do the cross multiplication. ds equals to v dt. ds equals to v dt. Then instead of v we are taking this expression. ds equals to v plus v u plus at into dt. v plus ut into dt. Both the sides we are taking integration. Integration of ds equals to integration of u dt plus integration of at into dt. Here integration differentiation cancel. You are getting s equals to ut plus a into integration of t into dt is the t square by 2. So finally we are getting s equals to ut plus half at square. Then third equation of motion is we have to prove that we know the initial velocity. The body is starting with initial velocity and after covering some distance its final velocity is v. So here third equation of motion we are taking v square minus u square equals to 2as. Just now we know this expression s equals to ut plus half at square. Instead of t we are taking change in velocity by acceleration. From this expression also you can take it. T equals to change in velocity by acceleration plus half a v minus u by a into t square. So after simplification, what is the common in these two? V minus u by a is the common. Here u plus half a into v minus u by a. This a cancel. Then s equals to, after simplification we are getting v minus u by a, and here v plus u by 2. Then we should get it here s equals to v square minus u square by 2a. So finally we are getting v square minus u square equals to 2as. This is the third equation of motion. Fourth equation of motion is how much distance covers in nth second? U plus a by 2 into 2n minus 1. Means last second, only in that particular time, how much distance it covers. You know that s equals to ut plus half at square. Suppose you are running in 10 seconds. How much distance you are covering? That is the s. In 10th second, how much distance we are covering? We should find out with the help of this equation of motion. Sn equals to u plus a by 2 into 2n minus 1. How to derive this one? Look here. One car is there. Starting velocity is u. It is traveling. Total how much distance is there? Sn is the total distance it is covering. Otherwise we can take it in n seconds it is covering s distance. Then it is the distance covered by the body in Sn minus 1. When we are simplifying these two expressions, so what is expression for s? Un, time is the n seconds plus half a n square. In n minus 1 seconds, in n minus 1 seconds, how much distance it covers? S n of minus 1 is equals to u into n minus 1 plus half into a into n minus 1 whole square. Now we should do that in nth second. How much distance it covers? Sn equals to s minus s of n minus 1. So we can get this after simplification, u plus a by 2 into 2n minus 1. So this is the fourth equation of motion. It is used to find out the distance covered by the body in particular time only. Suppose we want to find out in first second how much distance it covers, means instead of n we should write it the 1. If it is covered in third second how much distance, means you can go for instead of n we should write it the 3. This is the third equation of motion. Like that we can use one more expression for finding the displacement. Displacement equals to average velocity into time. What is average velocity formula? Sum of the quantities. Here how many velocities are there? Here two velocities are there. Initial velocity is u and final velocity is v, and average means sum of the quantities by number of quantities into t. So with the help of this we can find out. These four equations of motions depends on the situation we can use. Few problems we are discussing now. Simple problems. See. If initial velocity is 2 meters per second, final velocity is 4 meters per second, then time is the 4 seconds. So clearly we know that what is given data: initial velocity 2 meters per second, final velocity 4 meters per second, and they have given the time. How to find out the acceleration here? We can use the first equation of motion. V equals to u plus at. Instead of v, 4, initial velocity 2 plus time is the 4a. So after simplification, a equals to 2, 4a equals to 2, then a equals to 1 by 2, 0.5 meter per second square. Like that we should find out the acceleration with the help of the first equation of motion. One more problem we are doing here. See, if initial velocity is 2 meter per second, acceleration is 1 meter per second square, time is the 4 seconds. So the given data is, we know the initial velocity, we know the acceleration, and we know the time. How to find out the distance covered in 1 second? Which equation of motion is suitable for this? We can go through the s equals to ut plus half at square. S equals to u is the 2 into time is the 4 seconds, half into a into t square is the 16. After simplification you are getting s equals to 16 meters. This is the use of the second equation of motion, and that too these are the very simple problems. And third equation of motion, how to use this one? See, one body is started from 2 meters per second. Final velocity is the 3 meters per second. Acceleration is 1 meter per second square. We know the initial velocity, we know the final velocity, and we know the acceleration. But in this case, how to find out the distance or displacement traveled by the body is, we can go through the v square minus u square equals to 2as formula. Instead of v square, we are taking 9 minus initial velocity square means 4, 2 into 1 into s. Finally, distance is 5 by 2 is the 2.5 meters. 2.5 meters. And one more problem we are doing based on the fourth equation of motion. Suppose we are taking in nth second, we have to find out. N value they are giving 10. Initial velocity is 3 meters per second. Then we should go through the Sn equals to acceleration is 2 meters per second square. So here the given data is in 10th second, how much distance it travels means not in 10 seconds, only in 10th, in between 9 to 10, how much in 10 seconds, how much distance it covers, we should find out. Sn equals to u plus a by 2 into 2n minus 1. So Sn equals to, instead of u, you are taking 3 plus 3 by 2. Instead of n, we are taking 10. 10 into 2, 20 minus 1 is 19. Finally, you are getting Sn equals to 3 plus, this is after simplification, is 7 by 2. So, you are getting Sn equals to 6 plus 57 by 2. This is the 63 by 2 meters. So, this is the use of the first equation of motion, second equation of motion, third equation of motion, and fourth equation of motion, how we are utilizing the equations of motion. And these are the very simple problems. In further class, we are going through the few more problems based on the equations of motion. Thank you.